So in this section, we're going to take a look at what happens when you take two variables and connect them together. A lot of times in math, when you want to use math to solve problems, we want to do what's called modeling. And when that happens, a lot of times what we're modeling is how two different things interact with each other. So here's an example right here. It says the graphs below relate the height of the water to the volume of the cone. So if you look at the graphs, the x-axis down here, right, is the volume. So what happens as the volume goes up, what happens to the height? And the height is the y-coordinate going that direction. So I just want you to think about this. So pause the video for just a second. Think about that and see if you can match up those three graphs with the three containers that you have off to the side there. When you're done going through it, you can unpause it, and then I'll kind of talk about it with you. So if you look at this first container, right, as the volume goes up, the height is going to go up also. Same thing here, as the volume goes up, the height is going to go up on this one also. But the question is, which is going to go up faster? Well, because this one has a wider base, as the volume goes up, the height is going to go up slower. So I think those two would match up with each other right there. This one's skinnier, so as the volume increases, the height increases more rapidly, but it's like at a constant rate. If you look at this one, as this one goes, and this last one over here, at first, as the volume goes up, the height goes up at a constant rate. It's really similar to this one over here. But once we get up to the top part, now it's getting wider. So as the volume increases, the height is increasing, and as it gets wider, it'll increase slower and slower. So I think that one would match up with that one over there. But again, all we're doing is looking at that relationship between the two variables. In this case, the two variables were the volume and the height. So here's an example. It says the graph shows the volume of an air balloon as you blow it up until it pops. What are the variables? Well, it has that labeled here, right? The variables are, we've got time and we've got volume. So as time goes by, what happens to the volume? So we want to describe how they're related. Well, if you look right here, like this stretch right here, right? You take it, you start blowing in the balloon until you get to here. Okay, and then you stop to take a breath. So as time goes by, the volume stays the same as you're taking that breath. Then you're blowing again, so the volume goes up. Then again, you take a breath in there. Volume goes up, take a breath. When you get up to here, the balloon pops, so your volume instantly goes down to 0. So again, thinking about that connection, in this case, between time and volume. Okay, so look at A. What are the variables in each graph? And how do they relate to various points in the graph? So this one says board length. And then my variable is time and length. So if you think about this one, the board stays the same. Maybe you're sawing it, and when you get to a certain time, you get done, you saw off that part. Board length stays the same. You saw off another part. Board length stays the same. And that you saw off another part, and now the board length staying the same. Maybe you got to whatever length you wanted it to have. I'm going to skip by that next one. So I want you to take just a second. On number 1, I want you to describe a situation that might involve, so the x-axis is the number of pounds, so that's the x. The y is the total cost. So again, I want you to try to write something like some kind of connection between the time and the cost that would fit that graph. So pause the video, write that down, and then come back, and you can do it for number 1 and for number 2. So write a little situation that might fit those graphs. All right, so hopefully you have time doing that. The one I was thinking about is, if you have some kind of deal at a store where if you buy a certain amount, you pay a certain rate. Once you get past a certain amount, they have a cheaper rate, so it doesn't cost as much. So now as the number of pounds goes up, the cost is going up slower. Number 2, right, as you paint, maybe you're using like a sprayer or something to paint. As time goes by, or as the amount of area that you've painted goes, the amount in the can goes down. Okay, let's try something a little bit different. So on this one, it says a band allowed fans to download a new video from its website. The table shows the total number of downloads 1, 2, 3, and 4 days. Which graph could represent the data shown on the table? So you've got this table over here. So let's think about this one together, then I'll have you try one on your own. We want to see which one of those graphs fits that. So at day 1, there's 346. Day 2, there's 1,000. So that went up by about 700. Day 3, it's all the way up to 3,400. That went up almost over, 2,000, 2,500. then it goes up even more after that. So I think if I'm trying to match over here, I'm going to say it's definitely not this one, because this one, as the days go by, the number of downloads is getting smaller, and that's not what's happening there. I don't think it's going to be this one either, because that makes it look like the number of downloads is kind of leveling off, and I think they're not. I think they're increasing by more and more as I go down. This one is, they'd stay constant all the way up. I don't think those are staying constant, so I think it's this B right here. Right, as time goes on, it's getting steeper and steeper. You're getting more and more downloads. You guys try this one. So it has that table of sunscreen. Pause the video, look at that table, and see if you can come up with a graph that you think would best fit that. If you look at what's happening here, it looks like it's going down by a pretty constant amount. It looks like it goes down by 0.2, 0.2, and 0.2, so it's pretty constant. It's definitely not, let's see, it's definitely, there was one I was going to throw out right at the beginning. I don't think it's this one, even though this goes down by a constant amount. At the end, it's equal to 0. So at 3, it would have to be equal to 0. That's not equal to 0. This one is decreasing more and more rapidly as time goes on. So I don't think that's either. It has to be this constant amount. And then notice how this one's not 0. So if I had to say which one I think that is, I think C would match it the best. Okay, just try this. I want to do one more thing here. Let's get past that. I want you to try this. So I want you to see if you can come up, draw a graph that would fit this. So sketch a graph that would represent, and we want to do the height of the rocket during the height compared to the time. So draw an X and Y axis, make the X axis the time, and make the Y axis the height. I want you to draw a graph of what it looks like. So it says that it rises quickly. Then as the fuel starts to burn out, it slows until it finally stops, and then it begins to fall. And it will start falling more and more quickly until a parachute opens. Then it says, and then it falls kind of slowly back to Earth once the parachute opens. So see if you can come up with a graph that would represent it. So pause the video, draw a quick graph there, then we'll talk about it together. All right, so the way I would say is the rocket's at 0, and then it's going up, and as it goes up, it's getting higher and higher until the fuel starts to burn out, and then it starts to go back down. And it's getting steeper and steeper and steeper until the parachute goes out. Now the parachute goes out, now it's kind of, it's going down slower. It's kind of drifting out there. So that's kind of what mine looked like. It doesn't have to be exactly like that. This is the one that was pre-made on the slide here. That's not exactly the same as mine, but you can look at the different parts. Right, it's rising quickly up here at the top. It stops, and now it's starting back down, starting to fall quickly. Parachute opens, and now it's falling slowly back down to Earth. But that's what we're practicing. It's really just making those connections between two variables, and we can use graphs. One way to do that is using graphs to relate them. And that's what the assignment will be like. You're going to make those same connections as you go down through that. Anyway, thanks, guys.